Morning, everyone. Guess I need the backup good mornings. Morning, everyone. It's still technically the morning, so I can say that. Welcome to our event today. Thanks everybody for attending our Connected Vehicle Dataset Roundtable. ITS Georgia is excited to host this forum where we will learn more about connected vehicle datasets that can assist in overcoming challenges facing our transportation network and provide opportunities that we can look forward to in the future. Thank you to Peachtree Corners for having us today. Thank you to 360 Network Solutions for sponsoring the event today. And thank you to all of our speakers who traveled to be with us today and share this exciting information. Before we get into it, my name is Tom Glickert with Kimley Horn. I'm the president of ITS Georgia, and I'm thrilled to share some information about what we have planned this year. First and foremost, our organization doesn't exist without a group of dedicated volunteers. We sent out a call for volunteers in early January, and we'll be reaching out again in early February. Please consider supporting ITS Georgia and helping influence the future of ITS in the state and beyond. Be sure to pass this information along to any partners who may not be on our mailing list as well. Our members are equally as important to the success of ITS Georgia. 2023 membership is live, and I will give the floor to Troy Galloway with Arcadis, who's all the way back in line to give you all an update.
I just want to thank you to everybody that signed up for membership. We got the through January, so if you missed it, you missed it. We did get 27 people signed up, which is double what we had last year this time, so we're going to continue to grow this. If anybody wants to volunteer, we have about 4 people on our committee now, so if you guys don't start signing up, we're going to be calling you and emailing you. I'm also planning on next month being at the sign-up desk, so if you guys want to sign up in person and pay in, just let me know what I got.
Thanks, Troy. Do you have a question, Matt? No. We have some great content planned for the year. Emily Dwyer with GDOT, Mary Thamati with SEI, and Farrah Glasgow with Utilicom are leading our program committee this year, and I will hand it over to them for a brief update. Oh, that's you.
I didn't know.
You can go up. I just want to share the mic.
No. Thanks, everyone. So I'm Mary Thamati. I'm SEI. I'm with our programs committee. So we've got a bunch of new programs coming up. So today we've got our roundtable discussion, and Matt's going to be moderating. And we've got next month we have with AI, and we're working on that. And we have a couple of programs planned out. So we're going to send out some e-blasts with all that information. So look forward to seeing you all at our monthly meetings.
Thank you, Mary, Emily, and Farrah for all the planning you guys are doing. And we look forward to sharing some more of that information with you all shortly. ITS Georgia is committed to growing the engineering community in Georgia. As such, we'll be providing regular updates and sharing news from STEM communities throughout the state. If you have any updates you'd like us to share on your behalf, please reach out to me at president@itsga.org. One such group, Science ATL, which is dedicated to supporting the K-12 STEM community, is looking for volunteers on March 9th to do in-person or virtual visits to classrooms throughout the metro Atlanta area to share your journey in the STEM field. We'll be providing some more information on this in an upcoming e-blast in early February, but hopefully that's something some of you can get involved with and share your journey in your STEM field. ITS Georgia stays involved and engaged with ACEC and the legislative community, so I'll pass it off to Matt Glasser with Arcadis for a quick update.
Thank you, sir. So for those of you that are not knowledgeable about this, ITS Georgia, along with the other engineering associations within Georgia, all partner up with ACEC as part of the Georgia Engineering Alliance to bring all of our thoughts together, our concerns, get that funneled into ACEC, who then takes that over, and hopefully we can move the needle at the Gold Dome. And so as part of that, what we're able to do is, like I said, bring our concerns, but they also are able to share some great information back with us. There's a whole slew. I'm always happy to give you the full debrief, but some of the more important things that I do want to make sure to share with the community are as follows. If you are not familiar with this, our engineering licenses, fees, and renewal rates have changed. They are $100 every year as opposed to $25 every 2 years. So please make sure to renew those so that you're not having your license lapse. If you are a structural engineer, that actually counts as 2 licenses, so you have to pay $200 every year. So sorry about that. But the great news is that we will now have, on the engineering side, our own board who can do investigations, can hopefully speed up renewal processes, process applications a lot faster. Coming up this legislative session, there's going to be, we expect a large effort from the state on workforce development and retention that will likely look like pay raises for the government, so great for you guys, but also some money going into apprenticeship efforts that have previously gone into the contractor community. Additionally, and this is probably more towards the private sector folks, there's going to be a large push for tort reform this year that ACEC will be pushing that will, if you didn't know, and I did not know this, apparently Georgia is #1 in the country for punitive damages. So that's something that we are hoping not to be #1 in anymore. And so that might look like seatbelt reform, whereas if you don't wear your seatbelt and get in a wreck, that can't be brought up in court and used against the person. That can only be used against the engineer, apparently. Additionally, there's hopes that there'll be adjustments in Apex doctrine, which is the ability to call CEOs to testify. And then finally, for those of you that have been tracking this over the past few years, there's been some pretty heavy lifts about studying freight within the state of Georgia. That all got finalized this previous year, and one of the large recommendations that came out of that was an increase in funding, a recommendation of increased funding of $1 to $1.5 billion with a B dollars to transportation in the state of Georgia. Obviously, I think all of us will want to be tracking that quite closely, but that could be another HB 170 moment for us. So keep your ears open for that. And finally, there will be an engineering day, Tuesday, February 28th. If you are interested in that, you can register with ACEC, but that will be specifically downtown at the Capitol. And I'll hand it back to you.
Thanks, man. And that engineering day is connecting our community with legislators, right? So I think it's a good one for us all to be involved in. And thank you again, Matt. So like everybody, we at ITS Georgia like to have some fun. Not all fun, but some fun. Madison Dormini with AECOM is leading our social committee this year. We're kicking off the year with a gathering at Sweetwater Brewing Company on February 16th. More information on that to come in our early February e-blast, but we hope to see many of you there to share in some much-deserved networking. Finally, I have some news to share about the 2023 annual meeting, but before I do, I wanted to take a moment to recognize Mike Holt with Stantec. Mike chaired the Southeastern ITS Summit, which took place at the Hyatt Regency Hotel in downtown Atlanta this past November. This event brought together over 890 transportation professionals from across the United States to collaborate, network, and build off each other's successes. We had some amazing guest speakers, some really tremendous panels, and we hosted, all said, over 80 technical presentations and 3 technical tours. So please give Mike a round of applause for making this event such a success. And thank you to all the volunteers in the room who were able to participate and engage with that summit. All right, on to the 2023 ITS Georgia annual meeting. It'll be taking place in beautiful Jekyll Island, September 24th through the 26th this year. Holly Painter with KCI is chairing the conference this year. The call for volunteers and papers has gone out, and we will be providing periodic updates and opportunities for involvement and periodic updates on the technical program. Sponsorship and exhibitor opportunities for the conference will be opening shortly, so please keep your eyes out. And then before we get into the content today, I'm pleased to hand it off to Rachel Cohen with 360 Network Solutions, our sponsor today, to give a brief update. I'll bring the whole crew up, why not?
Do I talk in the both? Hey everyone, I'm Rachel Cohen. For those of you who don't know me, I'm the Vice President of ITS Georgia and also with 360 Network Solutions. We are an innovative technology provider, not only providing hardware but software solutions as well. A lot of you are our customers. Some of you who don't know me, love to talk more with you. Not only do we provide hardware, but we also provide software as well. Access cameras, Cisco network gear, and a slew of other things. So I brought Hadi Daradel, Director of Technology, to kind of give you an overview of some things we've been working on over the past year.
Good afternoon.
The whole book.
Like this?
Yeah, all of this.
Hi guys, good afternoon. My name is Hadi Daridel. First of all, we are here to support the ITS community, and there are a lot of good things happening at the 360. We have implemented the largest truck parking availability for I-10 TPAS coalition, which is Texas, Arizona, New Mexico, and California. We are actually implementing for the state of New Mexico for truck parking availability using millimeter wave and machine vision technology. Also, and we are securing the edge at the cabinets. We designed a smart lock, which we did a pilot in District 6, Florida. Was a very successful pilot, and they are replacing all the actually number 2 keys and every lock, and which is 750 locks. Also, we are implementing the wrong way for Florida District 1 using existing infrastructure. Also, and for North Texas Tolling Authority, we are implementing automatic incident detection using machine vision, which is the largest deployment of automatic incident detection. And finally, and not the least, and we are doing the largest fleet connected vehicle for this beautiful state of Georgia, for Gwinnett County, for emergency transient and DOT vehicle. And I'll be around if you have any questions regarding any technology or anything that we do. But thank you very much for your time. I appreciate it. Thank you.
Thank you, Rachel, Heidi, and 360 Network Solutions for sponsoring today's event. Before we get into the content, one quick announcement. Trash and recycling, back corners of the room. If you could, yes, Chala, give me the shout out back there. Chala just recycled something, so extra credit. So on to our presentation. I'm pleased to hand it off to Matt Glasser, who's going to introduce our guests and moderate the forum.
Sorry, you guys got to hear me speak twice. So I'm particularly excited about this. I think we've managed to make January our big data monthly presentation for the last couple of years, and we continue it on this year. For those of you that are not familiar, I'm a huge nerd about this. I think I've dragged probably about half of you guys into some kind of training with me, so appreciate you coming back out to humor me. This newer one, and the one that we're particularly excited about, that we're going to be talking about today, is around connected vehicle-esque data. So not your capital C, capital V, DSRC data, but data coming directly from the vehicle that's then processed in the cloud and then available to all of us. And this has been made possible through contracting that GDOT and ARC have done with the Eastern Transportation Coalition. The speakers that we have before us
all have open contracts with Georgia. So if you are interested in seeing more about this, this is a great opportunity to learn, A, more from them, and also a hurdle has been removed from a contracting standpoint. But again, as we're going through this, and I don't want to spoil what they're going to be talking about, this particular data is one that has been emerging. There's a lot of interesting areas that you can go into, but a lot of open questions that I think that the community at large outside of Georgia are still trying to figure out. So I think what I would love for this community, other than poking and prodding our speakers, nicely of course, is that we figure out how we can be leading the Southeast and the East Coast with using these new data sets. So I have 3 speakers here. They're going to each be doing about 5-10-minute presentations just to kind of give you an overview of what we're looking at, and then we're going to open it up for questions. I have my own questions, but I think you're probably going to have better ones than me. So let me start first with Jim Hall. Jim Hall has been working with technology for over 30 years. He started his career as a photogrammatical land surveyor. After time in the field, Jim transitioned to GIS programming and processing before moving into consulting and implementing integrated enterprise solutions. Jim has completed over 250 technology-centric projects for over 100 customers in the US, Canada, and the Middle East. He has been based in New York City since 2000 and now leads a team of technology professionals that develop and deploy cutting-edge solutions for a variety of government and nonprofit clients across the country. Terry Johnson leads the NRIC's Public Sector Services in the Southeast, a leader in the field of ITS and traffic management. She brings over 30 years experience in providing solutions to agencies so that they can best leverage big data to enable actionable insights. Terry is passionate about data analytics and to improve safety, reduce congestion, and empower agencies to optimize their roadway network. Terry has a BS in civil engineering from the University of Wisconsin. She resides in Dallas and is most proud of being a mother of 2 amazing twin 24-year-old girls. And finally, Robert is a certified professional transportation planner and trusted advisor for transportation projects, big data, and tech solutions. He has worked on planning, engineering, and construction projects and leverages his professional experience and practical knowledge of the big data and tech spaces to advise clients on solutions for their unique projects. Robert has worked on land development, infrastructure, traffic operation projects. He has also guided public and private sector clients on solutions for applications and travel demand models, population movement studies, transit studies, and many other projects. So with that, if you would, give me a round of applause for our speakers. And I think I'm going to have all 3 of you all come up. We'll take seats here. Terry, I'll let you go first, if you'd like, for your presentation. And then Jim will have you go next.
Set me up here.
Let's do this.
And I think I have a clicker. I think I have a clicker. I'm going to have to go like this because so it's going to be interesting. We're talking about connected vehicle. What's been super exciting about in the last few years is the number of vehicles that have GPS data devices in them. And so I've been in this world of collecting data for 20 years. I was with a startup that did that. But what's exciting is more and more vehicles have this data. Some vehicles, like the high-end vehicles, had it 20 years ago, but now we have, and correct me if I'm wrong, Jim and Robert, but I think about 2016, more and more car companies started to add these devices, and so now we're able to track more. And you're saying, well, who cares? Well, I'll tell you why. No, because I care. I'm just going to do a quick, just a quick overview about NRICS, but the reason I wanted to show this slide is when I first started about 20-some years ago in this world, we were excited to get 1 million points of data a day. I mean, it was like, oh, we reached 1 million, oh, we reached 2 million, we reached 3 million a day. And as of right now, we're collecting over 33 billion data points a day. Okay, that's why we're excited about this connected vehicle, and that's why Matt wanted to invite us to talk about this, because this has really only happened, I mean, obviously we're getting more and more data, but the kind of the big, huge, amount started about a couple years ago, like 2019, 2020, when car companies started to add larger amounts of data. So that's kind of what I wanted to show you there. I'm showing you why this matters. So these are some of the customers that INRIX has. And these are similar to the customers that some of the other people who will be speaking today and some of the other companies that do work in this industry. We all have kind of similar types of people that we provide data to. But all these people are using this data and trying to get where they need to go, how to get there, where they want to go in real time, and then also studies. I know I've talked to a couple of people here, and they were talking about different studies that they do. And by having this huge amount of data, we're getting data on not just the main roadways, which is how it all started. We were getting data on the freeways, and we were excited with that those million points of data. But now, since a lot of vehicles have this data, we're getting it really on almost all roadways. And so we can provide that data and for a lot of different, and can help us in a lot of different ways. I talk about waypoint data because this is one of the ways we typically use this data. So we're getting data from connected vehicles. And then we also, at INRIX, and some of the other folks that get the same thing, but we're getting data from fleet vehicles, which is something that we've been getting for a long time, in delivery vehicles. 20 years ago, a lot of truck companies would have GPS devices on their trucks because they wanted to know where they were. And so we were collecting that. But now, like I said, more and more vehicles have this data. We're also getting data from mobile phone apps. So I think some of you that I talked to said the reason they came today is because they want to know how to opt out. It's pretty easy. Just Google it, and they'll tell you how to do it. But that being said, you're being tracked. So and it's like I said, we're getting it from long haul trucks, and once again, just a lot of data every day. When you talk about the waypoint data, what companies like us and the other two gentlemen who are going to be speaking is, what we do is we take this data, and we're talking, like I said, 33 billion data points a day. We're taking that data and we're making sense of it. And I know a lot of companies are like, oh, we're going to do this, we're going to do this. It's not as easy as everyone thinks. It is a little complicated. I mean, when you get that amount of data every day, you've got to figure out, what to do with it. You got to take it, you got to cleanse it, and then you got to map match it. So what we do is we map match it to the roadway. We provide that data in real time. We archive that data, and that's a lot of processing that you have to do. So it's a bit sophisticated, and believe me, I don't do that. I just talk to people about it. And here are some of the ways, this trip data, so what we can do is we can help agencies understand where people are going, how they're going, where they're going to and where they're going from. You can do before and after studies. There's a lot of different ways that you can use this data. Here I talk about transportation demand, internal, and external studies, origin, destination, project performance. If I did a project using this waypoint path data by tracking these vehicles through different areas, you can understand what's happening. You can do a before and after. If you do single timing, you can understand, did that really work? Did that really improve the system? Construction, did that matter? Where are people going if you have construction? Are they taking alternate routes in different roadways? What do I need to do on those roadways? Do I need to change the single timing? There's just a lot of different ways that this data can be used. And what I have just on this slide are just some kind of, I want to say unique, but interesting different ways that this data has been used on different types of projects. Different things like truck parking. There's a truck parking study that was done to identify trucks that were on the sides of, on the ramps, so kind of understanding the waypoint data is from the connected vehicles, from connected data from trucks. But there's a lot of different ways, freight studies, origin destination studies, as I mentioned, travel demand models. So that's kind of the quick, am I under 10 minutes? Because Matt knows me and I can talk forever and a lot. But the waypoint data and some of this data, it is available. Currently, GDOT does have that data available to GDOT and public sector agencies and their consultants. So if you're working on a project, you can get access to that data. And I think that was all I needed to say. Is that good? Okay. Thank you. Oh, wait. Thank you.
Jim, I'll bring you up next. And Jim will say this, but Jim represents a company called Stellar, who actually represents 2 different data sets on the coalition's contract.
Great, thanks. And this gets clicked on, right? Thank you. All right. Thank you, Matt. Thank you, Terry. I'm Jim Hall, and with a company called Stellar Services. We're about 30 years old. Our second biggest office is in downtown Atlanta. Our biggest is in New York City, and that's the office I work out of. We're really a systems integrator, an IT solution provider, but we do, can you hear me okay? I guess I should be using this. Okay. We work with transportation customers. Our very first customer was the Port Authority of New York and New Jersey, and we've been there for 29 years. New York MTA, Atlanta Hartsfield has been one of our long-term customers. And so as Waypoint and OD data, all of this has elevated itself, we've become very interested because our customers we're doing analytics for them using these products. We don't produce any data sets ourselves, and if you know our contracting situation with the Eastern Transportation Coalition, we are the prime contractor, but we have right now 7 official partners, and we're adding 2 more. And all of these partners, most of them are data providers. So Matt said 2, but we actually, I think, have 5 firms that are providing data right now. And then we have a couple of service firms that we work with routinely, and they want to be able to allow them to be procured quickly through the contract. So basically, because it's such a strong contract that exists right now, you can buy right now, it avoids procurements. And that's the real attractive piece of this setup. So quickly, I'll get started. And maybe I'll do like Terry, I'll walk over so I can see what I'm doing. And just to let you know, it was funny, Matt said I got started in photogrammetry, so I come out of a world of accuracy, and I think Terry, you did too? Yeah, I did a lot of paneling and that sort of thing. I remember like the Conway bypass that runs from I-95 to Myrtle Beach. I did all the photogrammetric panels for that. Dulles Toll Road, all that sort of thing. So accuracy is in my head all the time. And a lot of the data that's coming in now, the collected vehicle, the LBS, accuracy is not really sometimes there. And so you have to work on that. And our customers know that, and they want us to work on it. So quickly, one of our data providers is Michelin. They have a whole range of OEM data providers that they buy data from. It's all anonymized when it comes to them. We never see, like Matt was asking me earlier, do we have privacy concerns? We never see anything. Everything comes to us anonymized from every vendor. So that's one perspective. I know other providers it may be an issue for. Michelin is based in Europe, but they have in the States about 30 million connected drivers in this country. And as I was talking with Terry earlier, these providers, whether it's Michelin or our other partner, Autonomo, they're adding providers and dropping them routinely, more adding. So their data sets are getting bigger, more accurate. They're spinning off products to analytical products that are not just the raw waypoints, but our safety data or stop signs, traffic lights, hard stops, that sort of thing. Autonomo is really, that was our second data partner to join the team. They're out of Israel originally, but in the States they have, I think it's about 50 million vehicles globally, I think about 10 million of those in the States. And they're adding data providers as they can. Other waypoint data sets through our coalition, we resell all of the Locus products that come from Cambridge Systematics. They're one of our partners. We have Driver's Seat reselling their driver activity through us. If you don't know Driver's Seat, they're a competitor, they're a cooperative that was, Uber drivers got together and said, we're tired of getting ripped off by Uber. We're gonna basically make our own app. And so you can ride them just like you can with Lyft or Uber. They resell that anonymized data through the coalition. Michelin, we have things like harsh accelerations, intersections, near misses. These are derived data sets that are available, just like INRIX has, just like AirSage probably has too. Is my voice cutting in and out? Okay. And then we have some products too. We know that these data sets are huge. Like Terry said, billions and trillions of points. And that's been the challenge for a lot of our customers. So we've worked with partners and we've developed our own middleware to be able to process these really huge data sets. The first one we started using was a product called DB4 IoT. It's a company based out of Oregon. They are a middleware package that basically they'll read in any data set and allow you to work with it and develop analytics. Do processing through it too. It's very efficient. The good thing is they host the data for you because hosting can become a huge issue with these data sets. And so they offer to take, if you're willing to host internally, they'll work with you to set it up on your servers, but they also offer the hosting if you don't want to take that on. Some other things, in the last 6 months, we developed the Stellar Waypoints GIS connector. And what that is we have a lot of ArcGIS users, whether they're using web or desktop or just doing automated analytics. They need to work in an Esri-centric environment. And so we built a custom solution. It's basically middleware that sits between the waypoints and the people that need the analytics done. And it does the processing. You can configure it. Basically, it'll take all those waypoints and aggregate them on center lines. So if you want to know average travel speed, any parameter like that, we can add it as an attribute to an Esri geodatabase or a REST endpoint. We've also developed recently this product called MMZip. Basically, it allows the size of data sets to be reduced significantly. It's lossless, so there's no degradation of the data. It just allows for efficient movement and use of the data. And then we, like many of you in the room, we all see the potential of waypoints. It's a matter of finding the right use cases. And Matt asked us beforehand, what are some of the compelling uses that have really got us excited? And we could talk long at that, for sure. We had done a project recently where we looked at hurricane evacuation and the traffic coming from the coast to figure out where were their bottlenecks. And we worked with 7 DOTs in the Southeast to help them look at, could they open up alternate routes, widen roads, that sort of thing, change signal light timing to get people away from the coast and inland. So I'll just run through these real quick. Terry identified several that were equally compelling. We can detect accidents in near real time. We know like North Carolina Thruway Authority is doing that right now. We heard earlier one of the speakers talk about North Texas is trying to do that. These are very compelling applications. We can automatically generate the origin destination matrices through an automated process now. We can plan better and safer evacuation routes like we did for those 7 DOTs. We can identify crash and near-miss hotspots to basically enhance your accident location analysis and planning. We can locate road hazards like potholes. The accuracy of some of these data sets is so accurate that if the vehicle moves 2 or 3 feet either way to avoid a pothole, and that can be seen as a repeated activity by multiple vehicles, you know there's something there. And based on the behavior, you can tell if it's a pothole or some other road hazard. So analyzing weather impacts, we can look at the impact of rain, fog, other events, snow. We can better calibrate the traffic simulation models. We're helping New York State DOT do this right now. And then we see there's really great potential to look at the use of greenhouse gas emissions for customers like state DOTs. So all kinds of compelling use cases there. One, I wanted to build on what Terry said. We had recently done an analysis for New York City DOT where they wanted to look at local traffic patterns and congestion around a baseball game. So we took the Mets played the Pirates over the summer, and we looked at congestion right around the stadium. And through waypoint data, we were able to see that very granular movement of cars before the game, during the game, after the game, and allow them to look at some of the ways that they could change the traffic configuration to get people in and out better. So thank you very much. Appreciate the opportunity, and happy to hand it over to Robert or Matt.
Unnecessary middleman for Robert to come on up next.
Thank you. I'm not sure.
Good morning, everybody, or good afternoon now. Robert Kohler from AirSage, and AirSage has been around since 2000. So back in 2008, we really began focusing on transportation, which is kind of the crux of my career. So I'm definitely a plan engineer by trade, if we can coin that term or leverage it. Worked in planning, design, engineering, construction, implementation, ITS, all that fun stuff. What I bring to AirSage is that knowledge, along with other transportation planners. We began working with mobile data for transportation in 2008. That was the first way to reasonably look at how people move around a region or a city, which is what we're all here to plan around. We plan movement, whether it's a car, a heavy vehicle, people walking, biking, scooting, whatever method they're using. That's why we're all here to improve what I call the complete transportation network. We're not just doing roads. In 2017, we shifted to LBS data, which is super granular, highly accurate data. Whereas with carrier data, we could look at 1,000 meters around a device, maybe put somebody in a neighborhood. Now we can put them on a roadway with their phone. 2012, we began working with connected vehicle data. Obviously, the mode of choice for that is all vehicle data. But so for that, we got increased resolution, high fidelity, highly active pings. So it's kind of like going from standard definition to high definition TV. So now you might wonder, what do they both look like? If we're looking at a trip in New York, I think it's outside Syracuse or Rochester, the trip began at about 12 o'clock if you're looking at plan view, went counterclockwise down to 6 o'clock. These are discrete individual pings from a mobile device. Granular enough to understand what the trip was, raises questions, maybe, why didn't they just shoot down the main corridor? Maybe there's a bunch of traffic signals. A lot of stuff transportation planners and ops people want to know. But the reality is, until you look at timestamps and actually understand how to look at the data, the pings are not individually spaced at the same distance with a mobile phone. So when you see at the top at about 12 o'clock a bunch of pings, it doesn't mean that it's congestion. In this instance, it actually means simply that there were a bunch of bursts for a GPS ping coming from the phone at that time. Whereas if we look at connected vehicle waypoint data, the stuff's amazing. This is looking at the western side of Baltimore on I-65. We can zoom in and see roughly every 3 to 5 seconds, you get a ping of where that vehicle was. You get the vehicle heading, vehicle speed, instantaneous speed. So the days of looking at detector-based speeds to understand the average speed between detector A and detector B, which might be a mile away, the average speed could be 55 miles per hour. But if the trailing speed is 75 miles per hour, they hit a hiccup and they go 25 miles per hour for 100 yards due to maybe an asphalt pavement condition, debris in the roadway, any number of things. It doesn't really indicate the true value of what is going on along that segment. That's where this stuff comes in great handy. So the output, what we work with at AirSage is typically CSV output. We work with power users. Typically people who get our data, it's not something you can open in Excel. It's not a spreadsheet that you're gonna try and filter a billion lines of anything in Excel. It won't happen. So you have to know how to bring it into GIS or a cloud-based solution oftentimes, which is why what Jim was talking about, you need to know how to work with gobs of data, how to move it. You can't filter through 12 billion lines of data without knowing how to work with data, which then turns into, okay, if most of us don't know how to do that, we need to work with people who have a platform, who can develop something custom for us to work with. Maybe it's simply looking at average vehicle speeds by roadway segment, which is a good indicator of congestion. All these different things. Most of us are probably never going to work with the raw waypoint data. But again, mainly because we know our users. I'm a transportation guy. I can say I'm very nitpicky. I'm very critical. Working with land developers and other people, they didn't care for retail site selection if it was perfectly ideal data. And on our end, working with the CSV, it's just maximally efficient. It's good for any platform for the most part. So operations people love data. Even if we don't use all of it, we want to know what is going on. The granular level of insight increases level of confidence. We do not want to propose a roadway improvement project. If a turn lane costs $500,000 to design and construct, you don't want to look at an interchange or widening the perimeter based on inferior data. The data is not cheap, but it's extremely telling and supports what we're trying to do. It could even just be an ITS deployment along a corridor like North Avenue, Ponce, maybe 11 or any of the other roadways. So these are the things we can do. Now this is what really excites me. We can look at the roadway insight. Again, vehicle speeds are very telling for operations. If we know the number of lanes on a roadway, we can see how vehicle speeds change by time of day, by weather events and things like that. We can also see a before, during, and after evaluation. We can look historically back at what the operations were before land development projects came online, before the Battery opened up for a new baseball park in the northern suburbs of Atlanta. You can't do that if you didn't collect traffic count data. So that's where CV data, we can look back in the future, back in history to see what was going on. Speed profiles, a very big thing we're getting into. We're now working with cities on presenting how you can actually look at the impact of a speed camera, specifically in Maryland. Do people slow up at the camera and then speed up? I'm guilty of doing that on normal occurrences. Detour behaviors. North Carolina is looking into this, where are the people detouring the way we told them to during a construction or emergency event, or are they going their own way based on Waze and Google Maps? OD studies and a bunch of other things like that, travel demand modeling, those are other elements. But thank you. So we'll have our speakers go ahead and come up here, take a seat. Or is it switch back and forth between the mics?
So kind of finding you guys, right, for the last, 10 plus years, we've all been very excited about the prospects of a connected vehicle world. And we've heard all of our analogies of, my God, this data is going to fill this many Olympic-sized swimming pools, it's going to be that, it's going to be the other. And that is not to say that it won't be. But what we have here is a sampling of that. And as you've already heard, it's an outrageous amount of data that we've got to figure out what to do. And so I think it helps launch us into a great place to figure out what's going on, what actually is actionable, what do we want to be looking at, what's it mean to sift through that, sort through that. And so I want you to kind of put that hat on as you're thinking about this, as you're coming up with your questions of all these promises that we've had and all these hopes that we've had for the last few years about all the changes that a connected vehicle world can make. This is that starting point. It is here, and you don't need the hardware in the vehicles, and you don't need the hardware on the signals to start making it happen. So I have a whole, like I said, a whole slew of questions, but I don't want to suck up the time. So if you have your questions, please feel free, and when there's gaps, I will slide in here. So I got one, and then we have two.
Is it fairly easy and routine to be able to determine the lane a vehicle is in? Of course, the reason I'm asked the question has to do with traffic control and tolls. So on Peachtree Street, can I tell what lane it's in? And on I-75, can I tell what lane the vehicle is in?
Who wants to answer that? That's a really good question. Can you hear me?
Yes.
Okay. Yeah, I see what you mean. Yeah. When you talk, so that is a really good question. We're working on that. I mean, correct me if I'm wrong. I think we're within couple meters of, when we get the GPS data from the vehicles, we're within a couple meters.
Yeah, unfortunately, I grew up with a farm field in my backyard. How close do we think we know where a tractor is?
There's some my father's a contractor, yeah. There's some pretty accurate stuff.
Couple of inches.
Yeah, there's some pretty accurate devices that are used for construction, for farming, huge. I mean, that's really where a lot of this started, was obviously military, right? And then that went to farming and went to construction. But the stuff the data we're getting today isn't that I don't know, yeah,
It's
right?
not gonna be the inches.
It's not gonna be inches.
Yeah.
I mean, obviously it's coming. We're trying to do stuff where we can try to figure out when we deliver the data by lane, but it's not there right now. But you're absolutely right. Farming, it's different. It's a different device.
And to add on to that, so the width of a travel lane is roughly 12 feet. So I think that's roughly about 4 meters. Now, I don't know if the device is in the middle of the car, to the left wheel well, to the right wheel well. Those are meters apart. So when we're dealing with all this stuff, there's no absolute, fully certain way to put somebody in a travel lane. And if you're in the middle travel lane of a 3-lane direction, you could physically be in the left, middle, or right lane, because it could be off by 3 meters. So we're not quite there, but we can make a lot of inferences. If you have a general purpose lane on 85, and you have the hot lane on the leftmost lane, or toll lane, whatever we want to qualify it as, the vehicle speeds are going to indicate, typically, if the general purpose lanes are slower, we can use other details to put people into a general purpose lane or a toll lane. That would really be the best way to do it, but to look at peak lane utilization and things like that, we're not quite there yet.
And even we have a toll road customer that wants to manage one lane, and we put supplemental IoT devices down on the ground that give us that accuracy so they know whether the vehicle's in the lane or not.
Yeah.
But the raw data coming from the providers, it's just not accurate enough today.
So one of the bullets that you had caught my attention, the detour behavior. So have you used that feature already somewhere? And I know this might be a very specific question, but
Yes.
do you know if there is a comparison of actual data and what it was projected before?
So what I think you're asking about is ground truth data. To understand the waypoints of ground truth is almost impossible. It's infrastructure based then. It's why using it's not antiquated technology, but Bluetooth readers were great to have for travel time. That was better than nothing. Now we can use, Easy Pass and stuff like that. But when we got to the idea of are people detouring where we want them to, unless you're having a lot of LPRs or other element in the field, you're never going to be able to do it. But what we can look at is a sample of the vehicles on the roadway, understanding that compared to 5 years ago, the representativeness of our population in a connected vehicle is much better. I rented in Florida the lowest end of either Honda or Toyota. It was absolutely a connected vehicle, and in fact, it told me I needed to get gas or I would run out within 50 miles. Didn't make me happy, but it might have been for asset management on Avis's end. It might have been just, the auto manufacturer wanting to feed data back. But there are values to it, and it's becoming more and more the norm. So every day we get new vehicles on the roadway, the more representativeness we're going to be for the population, and more importantly, in 2 years when those vehicles go on the resale market, assuming used cars are going to get back to a normal price, we will have even a wider representation of the population where the lower income people can afford a connected vehicle.
Oh, no, but I was gonna say, I mean, the data we're getting is, it used to be Bluetooth, like you were saying, or Sci-Fi radar devices. I mean, we're getting the actual pain points for those vehicles. And so when you talk about detours, there have been a number of using, like through the RIDIS tool, evaluating detours and stuff like that. It's pretty common. And I mean, you're looking at actual vehicles. Do we have all of them? No. And do we know, are a lot of other vehicles going someplace else? Maybe. But I mean, even if you have a small sample, you have a sense of what's happening. And I know you're probably an engineer. I'm an engineer. But you know what? You guys kind of get over it. I mean, you know, you're not gonna have everything perfect. Oh, so, you know, we have consultants who are using, the waypoint data for, estimating volumes. In fact, in North Carolina, they did that. A company estimated volumes, and it was quite accurate. Even turning movement. So all this data, since there's so much data, we're starting to do volume estimates, you know, turning movement estimates, just because we have actual data and we have, you know, a decent percent, and we can, you know, calibrate models and stuff. And the models are now being calibrated with real data. Okay.
And I understand because right now, the only tool we have before we actually go into construction and detours is the travel demand model. And you know how realistic those numbers are. So that's why I was just thinking, I mean, is there a comparison of how the actual data compares with that, and does that tell us a different story?
Sometimes.
Yeah.
Mm-hmm. I mean,
And a lot of these solutions too, whether it's detour analysis or whatever, all three vendors in front of you, we sell multiple data sets. And we're finding that for almost any analytic problem, you're combining more than one data set to solve it. And so you need to know the strengths and weaknesses of each and what to use for each.
amen. Yeah, you really.
So, you all would, I guess, quickly, you know, you all mentioned some terms, LBS, waypoint, connected vehicle. Certainly, Terry, with you, right, you have the traditional speed and travel time. Could you explain to the crowd what those differences are between the data set titling, I suppose, you know, what that really means, right?
I'm not sure I understand the question.
So for example, are you getting it directly from a vehicle? Are you getting it through apps? Are you only getting GPS data versus like the full vehicle? So maybe like there are those subtle differences, right, with how you're building out your individual data sets.
Okay, so yeah, so we're getting data, so we get data from a variety. I think we have, we're a global company, but in the US we have over 20 data providers that we get data from. So some of it is directly from the vehicle, so it's a GPS, like the OnStar, let's say. OnStar data, there's a GPS device in the vehicle, so we're getting that data, right? We're getting data then from mobile phone apps. We don't do any LBS, we just do GPS. So we get the GPS, you know, data from phone applications. And then we get data from GPS devices that are installed in freight delivery vehicles, and also freight. Is that the question that?
Sure.
Is that the answer?
Feel free to.
And then we're also working with partners. We've been looking at, you know, a lot of the connected vehicle data, meaning like the heart braking, all that different type. We have we work with GM right now on doing that. We've been evaluating that data, I think for, I want to say almost 10, but let's say 8 years, just evaluating how to use it. It's starting now, really in the last, 2 years? The safety data is there's finally enough of it, and it's accurate enough. I think a lot of the work that we've been doing, and I'm sure you guys too, is telling the automotive companies, you can't deliver the data to us that way, or you need to do, you know, trying to educate the automotive companies on how they need to deliver the data so we can actually use it. So we're working with GM on a safety product where we have hard braking, we have seatbelt wearing, like, you know, yeah, I think that's, I'm trying to remember what else we have.
I think one other thing too is we all three of us offer an awful lot of data sets, but the use case, like what you want to use it for, is all important. And we're all three of us willing to consult on that and tell you our opinion and our experience on what we think the best combination of data sets is to satisfy that use case. So that might be one of the most valuable things you can get out of all of us. And that's generally, I think everybody would say up here, free for you.
Advice.
Yes, exactly.
Advice, yes.
Unfortunately, that's why we're all here. We like to advise people on options. Even if it's not my option, we don't always have a perfect solution. I'm very candid and provide that. Unfortunately, people might not be happy, but sometimes big data might not be the best solution. So sometimes there's a need for ground truth. But complementary data that works together is really the goal. And oftentimes, we have clients using our data and their data. It's because you can look at it different ways. You can slice it and dice it. These are expensive projects. So from like a travel demand modeling standpoint, we have consultancies using our OD data based on mobile phone
data because we get a much larger draw of the population to see the movements. We don't care exactly the path that they took, but when they use complementary CV data, they can see the path that the vehicles took. Not 100% of them, but it'll let them validate and calibrate their model more appropriately than they ever could.
Yeah, good point.
So just looking at 33 billion data points a day, just curious what it means to clean that, and from the engineering standpoint, what does it mean to put that in boxes and whatever else you do with it?
Costs a hell of a lot. Our Amazon bill is huge. So that's why, the data sets are a bit expensive. Well, I guess they're not for what you get, but there's a lot that goes on. When we started getting the growth in the data, we had to redo our whole system on how it processes data. We had to just kind of start over because it was just so much data, it was overloading the system. So yeah, it's pretty complicated. We have a team that's just all they do, a bunch of scientists who deal with that kind of stuff. I guess is that the question? Yeah, and then talking about different providers, we have a team that just focuses on getting new providers and making sure the data is worthwhile and doing that type of work also. But yeah, we had to redo our whole system once it got to that many points of data. And we'll probably have to do it again, I would think, just as it grows.
Yeah. And I might throw in too, like the AWS cost can be incredible.
Huge.
We self-host everything just for that reason. And we buy our own servers with fast disks that are optimized for data rendering and provision. So you have to play that game. There's many choices there. But then you saw too, I identified some third-party products that we've come up with. We have to be able to use the data. You just can't work with billions of points. So we have all kinds of middleware that either from partners or that we've created to make that happen. And you have to do that to get any analytics out of it.
And on our end, we went from an on-premises solution to a cloud-based because we would have had to keep continually updating and improving and adding to the servers. We didn't want to have a team dedicated to that. So for us, we have literally infinite clusters and storage capacity available in the cloud. It's quite expensive. The other thing to remember, moving this data around, I can't give you a thumb drive and say, here's your delivery. I cannot email it to you, definitely not an attachment. Digital download link will take you days to download, so.
Quick question. I know that for 33 billion data points, you're not going to be able to give any type of real-time information. But if you have a corridor identified, something specific, maybe 20 miles long, can you see down the future being able to give real-time information for that so that we can use it for operations?
It's already there, actually.
Yeah.
I think we've probably all had that data stream going to different clients. So it's near real time, it's not exactly to the second, it might be 10, 20 seconds behind, but that's literally real time.
You can do 20-second latency now.
We have.
Very good. What kind of accuracy?
Accuracy for what
Pretty
question,
darn
like
accurate.
speed
Well,
or what?
speed would
Yeah.
be number one, but volume would be very close behind that.
So volume is going to be based on the end user and how they want to expand it on my end. When it comes to speed, the speed is what the speed is of the vehicle. It's coming from the vehicle. So whether it's coming directly from the OEM or through like an OBD2 dongle, TSB equipment, which is telematics system providers, anything like that that's providing near real time, it's being read from the vehicle.
All right. That was worth the price of admission right there. Thank
Yeah,
you.
no, it's there, it's there.
But I'll caveat it and say it's not a low cost offering.
Yeah, but neither are
Devices.
by the field, so.
Yeah. No, that's a good point. I still have some clients, I won't name them, who, they use certain types of devices, and I'm like, are you kidding? And I think you need a combination. It does make sense to have a combination, but putting certain devices every, third of a mile on a freeway, sorry if I'm talking to someone, but I mean, I just, at this point, I mean, I did that, 20 years ago, where we were installing devices every third of a mile, then I went to like every mile, because the operation and maintenance was, too expensive. But we're at a point now where we're really, when it comes to speed and travel time data, those data sets are pretty darn accurate.
Yes, it's kind of related to his, but I wondered about trucks. We have a big truck corridor. Could we get kind of real time or at least a monthly record of what the patterns of the trucks are in that corridor? Can you break it down by trucks versus vehicles?
Mm-hmm. So yes, actually, so there's an NPM RDS data set provided by, am I going in and out?
Yes.
Okay, so FHWA is purchasing data from INRIX, and this data is available to all MPOs and DOTs. It's called the NPM RDS data set, and it does have speed and travel time data for freight and passenger vehicles. So that data is available. So if you're with an MPO or a DOT, you can get access to that data. It's available.
All right, well, thank you, Terry, Jim, and Robert, for coming out today and giving us the presentation on the data sets y'all provide. Thank you for some great questions from everybody out in the audience. Contact information was provided on their slides, so keep the questions coming. They said they give free advice, so I put them to the test.
I have a lot of advice.
Thanks everybody for coming today. I look forward to seeing you throughout the year. Got some exciting stuff coming up. Keep your eyes peeled.